Welcome to Tips Training and Certification Online Training Program. Today we will see the Pareto analysis. What is exactly the Pareto analysis? It is a technique which selects the causes or defects which significantly contributes to the effect. It works on 80-20 rule principle. What it means? In other words, we can say that by taking the actions over 20% of causes leads to reduction in 80% of defect. Other examples are 20% of operation accounts for 80% of scrap. Out of 12 unique services, 3 accounts for 82% of customer complaint and few students creates a bulk of problem. Now we will see the application of Pareto analysis. It helps in deciding the direction of analysis. It helps in deciding the training and retraining of the employees. It helps in deciding the replacement of machines. It helps in deciding the and selecting the areas of design of experiment. It definitely helps in identifying the areas needed improvements. What are the advantages of Pareto analysis? It is a first step in making the improvement. Every concern cooperates, has a strong impact. It is an universal applicability. It helps in selecting the concrete results and can speak the language of many as well. This is a typical Pareto diagram which is showing on the screen. How to construct the Pareto diagram? Now we will see in our next slide. Construction of Pareto diagram. This is the methodology given here. First, collect the data, cause or defect wise. Encode the cause or defect for ease of plotting the Pareto diagram. This encoding of data will reflect on the x-axis while drawing the Pareto diagram. Next, enlist the frequency of causes or defects in descending order. What it means? Starting from the highest value to the lowest one. This data will reflect on the y1 axis. Calculate the cumulative frequency. Calculate the percentage cumulative frequency. This data will reflect on the y2 axis. Plot the bar chart. Causes versus frequency of causes means x versus y1 axis. Plot the line chart. Causes versus percentage cumulative frequency means x versus y2. From the level of 80% on the y2 axis, draw a horizontal line towards left side which will intersect to the line chart. Now draw a vertical line from the intersection point. The left hand side of this vertical line represents the vital defects for which we have to carry out analysis in further steps. How to interpret this data? This is the standardized statement given for the interpretation. There are number of contributors associated with the effect, but these list of vital few items accounts for number of percentage of the total effect. We must pursue these numbers, that is the vital few categories, because they represent the greatest potential gains for our efforts. This is the example given for the explanation purpose of drawing the Pareto diagram. Step 1. Order the defect data and encode it. This is the customer complaint related to the order. The defects are related to the service code, address, copy, rate, credit entry and delay. The frequency of occurrences of these defects are 8, 20, 4, 32, 6 and 3. Now these defects are encoded in terms of SC, AD, CP, RA, CE and DL. Step 2. Rewrite this data in descending order. Means we have to start the defect frequency with highest value to the lowest value. Here the frequency of rate is 32, which is highest among the data. Similarly, next level is address, that is 20. Service code 8. Credit entry 6. Copy 4 and delay it is equal to 3. Total number of defects are 73. Step 3. Find the cumulative frequency. How to calculate the cumulative frequency we will see here. Now for the first, that is rate, the frequency is 32. Write it as it is in the cumulative frequency column. Next, for address, add 20 plus 32, that is equal to 52. Next, service code, 8 plus 20 plus 32 is equal to 60 in the cumulative frequency. Similarly, for the other defects, write down the cumulative frequency in cumulative frequency column. Step 4. Calculate the percentage cumulative frequency. How to calculate? We will see here. For the rate, cumulative frequency is 32. Total defects are the 73. So, percentage cumulative frequency will be 32 divided by 73 multiplied by 100 is equal to 43.83. Similarly, for address, cumulative frequency is 52 divided by total defects, that is 73 multiplied by 100 is equal to 71.23. Similarly, calculate the percentage cumulative for other defects. Step 5. Construct the Pareto chart. First, draw the x-axis with events. Draw the y1 axis that represents the frequency of occurrence. Next, draw the y2 axis which will represent percentage cumulative. Next, draw the bar chart x versus y1. Next, draw the line chart x versus y2. How to plot? Plot the cumulative frequency points x versus y2 and join them. Now, draw a horizontal line from the AT of y2 which will intersect the line chart. This line is represented in pink color. Now, at the point of intersection, draw a vertical line which will intersect the x-axis. This line is given by green color. Left hand side of this green line represents the vital few defects which are in real terms are the important for which we have to carry out the further analysis. Step 6. The interpretation of the Pareto chart. From the above data, we can interpret this data in terms of these words. There are 6 numbers of contributors associated with customer complaint, but this rate, address and service code are the vital few items accounts for 82.9% of total effect. We must pursue these 3 vital few categories because they represent the greatest potential gains for our efforts. This is another example of Pareto analysis. Here, downtime of machine for different defects are given. This is the Pareto chart drawn for this data. There are constraints while determining the and interpretation of Pareto chart. Example, if all the bars are of same height or more than half bars account for 80% of defect, then what to do? Simply stratify by cost or consumption. Means for the occurrence frequency, multiply by cost factor or consumption factor. Carry out the step as given previously in Pareto analysis and draw the Pareto chart. Now you will get the right results for these constraints. Now this is the another exercise given to you. Just solve it. Thank you.